Hello everyone, this is Mr. Rodriguez, making our first notes, first video for the 5th grade science here. This is the review of the notes that were covered throughout the year, through the beginning of the year, and I just thought that it would be good to have some videos that you can rely on to actually review some of the important content that was covered so far. So we begin here with the structure of the atom. Okay, so this is where the beginning of the year actually first began. We began with the structure of the atom. There are two basic structures. There are two basic, the basic structure of an atom is composed of an electron cloud and a nucleus. Okay, the nucleus is the center of the atom, and the electron clouds is what forms on the outside. Now what's really interesting is that the nucleus gives an atom its mass. So the amount of mass that it has comes from the center of the atom, and the electron cloud is which basically are the electrons roaming around, is responsible for giving the atom its volume. Now there are three basic particles that are found inside of the atom. There's the neutron, which has no charge whatsoever. It's neutral, but basically means it has no charge. There's the proton, which has a positive charge. And then there's the electron, which has a negative charge. Now, the neutron and the proton are found inside the nucleus of the atom and actually gives the atom its mass. The neutron and the proton are both 1 AMU each. So, for example, if we were looking at this atom here and we added the number of protons and the number of neutrons, we would see that this atom would have a mass of approximately 14 AMUs, because there are 7 blue spheres, or should we say purple spheres, and 7 blue spheres with pluses in them. So therefore the mass would be 14 AMUs. Now AMUs just basically stand for atomic mass units, which is the basic unit of measure for an atom. The electrons, which is negatively charged, move so fast that we cannot predict the location of those electrons at any one particular point in time. We can only assume where they would be, or where we will most likely find them. But they're roaming around in this shaded area called the electron cloud, and the reason why it's called a cloud is because the electrons move so fast that it creates a fuzzy structure, which is called the electron cloud. Now this is the periodic table, and the periodic table, what it is a list of elements, but each element is basically an atom with a particular structure for that atom. For example, if we take hydrogen, hydrogen has an atomic number of 1. This atomic number on the periodic table tells us that it has 1 proton, and if it has 1 proton, it's going to have 1 electron in order for it to be statically neutral. And what statically neutral means? For every positive, there has to be an equal negative. If it's not equal, then it becomes unbalanced, so then the atom has a charge. So if we go across the table from left to right, hydrogen has 1, helium has 2. We can tell from the basic number, the atomic number, we can actually predict the structure that the atom will have, and that's where the strength of this periodic table comes from. The periodic table organizes the atoms in such a way that it's nice and neat, and it actually aids us in actually analyzing structures of the atom. So let's say, for example, we're looking at lithium. Lithium is number 3. So 3 means that it has 3 protons. If it has 3 protons, then it has to have 3 electrons. So that way it can balance out. If it doesn't balance out, then it's going to have a charge. We can also assume that it's going to have the same number of neutrons. So the number of neutrons, we can say that we can assume that it's going to be 3, giving lithium a mass of approximately 6 AMUs. Okay, so the periodic table, basically what it is just an organized way of actually looking at all the atoms that we have found here on Earth. They're called elements because that's the name that they gave it, but just know the connection that each box actually gives us the structure of the atom for that particular element. Now, inside here, of course, I just wanted to just reiterate some of the information that you would find in the periodic table. In the periodic table, we would find something called the atomic number, which again tells us the number of protons found in the nucleus of the atom. We will find a symbol, which is the shorthand to represent that element. Rather than writing out sodium, we would just write Na, and we would know that that's sodium. And then the atomic weight. The atomic weight, again, is measured in AMUs, and the atomic weight is usually the number of protons plus the number of neutrons added together to give you the atomic weight. So to demonstrate this, we have this nice little activity that we have here, and I just want you to look at some of the numbers that happens here. Right now we have the atom structure, and again we have the basic structure, which is the electron clouds, which are on the outside, and we have the nucleus. That's the basic structure. And these are our particles that are found within the atom, and these are going to be the information that this atom, when we construct the atom, that will the information for that particular atom. So let's start with, let's say for example, let's begin with let's say we want to do boron. Okay, boron has 5 for the atomic number, so that means it's going to have 5 protons in the nucleus. So let's put 5 protons in the nucleus. 1, 2, 3, 4, and 5. And it's also going to have, so as we can see that as we're putting 5 protons in the nucleus, we can see that the charge of the atom is +5. So in order to balance out this charge, we need 5 electrons. So we have to put some electrons here. 1, 2, and right now we have 2 electrons, and as we can see, 2 electrons and 5 protons gives us a +3 charge. So now we have to add 3 more electrons. 1, 2, and 3. And now we can see that with 5 electrons and 5 protons, we have a statically neutral atom. It will have no charge. Right now the atomic mass is 5 because there are 5 protons and it doesn't have any neutrons. Now nature dictates that it must have neutrons in the center. Must have neutrons. Actually the neutrons aid in the stabilization of the nucleus itself. So neutrons must be present. How much are present is dictated by dictated by nature itself. But here what we did is we put 4 neutrons in the center. We have 5 protons and 5 electrons. As you can see, the atomic mass came out to 9, and the reason why it's 9 is because the number of neutrons and the number of protons when added together gives you the atomic mass of the number. Okay, so the atomic number again is 5. So we look at the atomic number for 5. So we go back to the periodic table, and atomic number for 5 is boron, as we can see there. Okay, so the number of protons in the nucleus indicates the number of the atomic number that the atom would have. Let's reset it. Let's try another one. So to try another one, let's go back to the periodic table and let's choose another element. This time we're going to choose silicon. Silicon has 14 protons, so we're going to add 14 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here we have 14 protons in the nucleus. It has a charge of, I don't know why it goes back to charge of 0.1 of +1. That's ridiculous. It would have a charge of 14 there. But of course, with 14 protons, we're going to make the atom statically neutral. So to make it statically neutral, we have to add the equivalent number of electrons here. So we're going to add 14 here. It's 5. And as you can see, the number of the charge decreases with each electron that is added there. See, 6. We have 8 electrons. 8 from 14 gives us 6. So we keep adding until it's statically neutral. And there you have it. So here we have 14 electrons, 14 protons, and the atomic mass would still be 14, but again, like I said, nature dictates there must be neutrons. And of course, we're going to add, in this case, we're going to assume that the number of neutrons is equal to the number of protons. So we're going to add, that's 6, 7, 8, 9, 10, 11, 12, 13, 14. So now we have 14 neutrons, 14 protons, which gives us an atomic mass of 28. The atomic number is 14, which if we go back to the periodic table, we will see that number 14 is silicon. So there is the structure of the atom. And that was the first notes that we had for the year. Okay, so these are atoms. Atoms again are just constructed by a basic structure. The basic structure of the atom is the electron cloud created by the electrons roaming around the nucleus so fast that it creates this cloud. The nucleus, which is the center of the atom, and inside the center of the atom we can find neutrons and protons. Protons are said to have positive charge, electrons are said to have negative charge. And I believe that's it for today. Thank you.